Want her voice back? Okay, so here you go. So look, what's going on here is the graph you see below, the graph you see right here, is the graph of this function right here. So this question for A is asking, where is that graph equal to 0? What would be the solution for A?
1, 0.
Yeah, 1. So to solve it, it's asking what are the x values? X equals 0 and x equals... Sorry, 1 and 3. Sorry, 3. Thank you.
How would you do like?
So then the next one,
Do the math for that?
You have to factor it out.
where does this function cross the x-axis? 1 and 3. Where does it? You're using the graph. You don't have to factor it. If you factored it, you could solve it that way, but you are given the key. You don't need to factor it. On this one, it's saying what x values can you plug in? What x values can you plug in to make the graph greater than 0? Well, the graph is greater than 0 here, right? And it's also greater than 0 here. What are the x values for there? What are those x values? No, to the left of 1 and to the right of 3. What are the x values? Correct, exactly. So for this one, it's going to be negative infinity to 1, and not including 1, because at 1 it's equal to 0, right? Union 3 infinity.
Oh, so it's just everything to the left.
And everything to the left of...
What's using unions in this part?
If it's asking you, this question is asking you in words, what x values can make this true? Those are them.
And that's because it's like the greater than?
Yes. If it was equal to, then it would be the hard bracket at 1 and 3.
Because it has to be greater than 0.
Exactly. So what about this one? You can do this one. Where is it less than 0?
1 to 3.
1 to 3.
Yeah, does it include 1 or 3?
Yes.
No, because at 1 and 3 it's equal to 0, right?
It's just 1 and 3.
Exactly. So it's going to be 1 comma 3. And this is this a point?
No.
Not a point. What is this?
That is
Interval. It's an interval. This is all interval notation. I like this because it's the least amount of writing and it's very clear. You could use a number line, you could use words, you could use set notation. I prefer interval notation. Some people don't like it when they do it because they're like, oh, they're points. Like it's not points. Yes.
We're not going to use
Yeah.
for like.
Oh, wrong one. I'm sorry. A over here. Sorry. X equals, these are single numbers because it's equals. X equals -4 or 2/3. 2/3. Excellent. What about B? Does anybody have B? Where's it greater than 0? Can someone tell me where it's greater than 0? Someone knew. Hannah.
2/3.
So you did 2/3 first? Okay, yeah. So 2/3 comma what?
Comma
And what? There's another region. Yeah, what's the left side one?
-4. No, wait.
Negative infinity to what?
4.
-4, yeah. There's 2. And what's C? Oh, different
You
question.
have to have the hard
brackets on
No, oh, thank you. You absolutely have the brackets. Why?
because it's equal.
Very good. Excellent. And generally speaking, you like the smaller ones to the left. So generally speaking, it's better to write it this one, union 2/3 comma infinity. Generally speaking, that'd be good. What about C here? Where's it less than 0?
at -4 to the
-4. And is it closed or open brackets? Open because it's strictly less than. So these make sense now? See, they're just trying to hammer like the visual way of doing this. So if you have an accurate graph, do you need to factor? Do you need to use the quadratic equation? Do you need to do anything like that? No. Let's solve this here. Okay, so what do we have here? We don't like 10x squared plus 9x minus 9 is greater than or equal to 0. We love putting it to 0.
Yeah.
At this point, what should you try to do? It's a quadratic. Try to factor it, right? Try to factor it. Does it factor nicely?
Yeah.
I don't think it does.
Does it? No.
What did you think? Oh, maybe it does.
5x minus 3 and 2x plus 3.
Maybe it does.
What did you do?
Let's try that. Hold on. So we got 10x squared plus 15x minus 6x minus... Oh, look at that. He factored it. Chris gets a gold star. I'll get you one. I have them, I think. Oh, excellent. Fantastic. Yeah, I didn't think they would give you one you couldn't factor. So what does that mean? We need to know where it equals 0, right? And then we make the zones. So 5x minus 3 is easy as 0, or...
2x plus 3.
Yep. So 5x equals 3, x equals 0, 5, 2x equals -3, x equals -3 over 2. So then you graph those points, right? So you have -3 over 2 and 3 over 5. And then what's a good number in between those two? What's the best number in between to test? How about 0? Test the easy ones, right? And what's really easy over here on the right? How about 1 and how about -2? So test those to see. We know here there's 0, right? There's 0 there, but we need to know if it's positive or negative in those regions. So remember what we did before? I don't remember who came up with it, but we have two things multiplied together, right? 5x minus 3 and what else? 2x plus 3. Let's plug in 0. Do you get positive or negative when you plug in 0? Negative and? So what does the product turn out to be? Negative. So that was in between. So this is negative. So yeah. So you know, I know it's going to go up there. Well, you'll see.
Wait, why is it negative, the product?
Plug in 0 right there. What's a negative times a positive?
Oh, negative.
Negative, right.
Oh, you multiplied it,
Like,
that's what that
like, do we care? Do we care what the number is? No.
Plug
We're,
in the number in between them to find what in between is.
exactly. So we know it's negative in between. So let's plug in 1 now. When you plug in 1, what do you get? Positive, and so the product is what? Positive. So over here it's positive. So then what do we plug in? -2. Wow. That was cool. I really want to know how that happened. Like, it wasn't a ringtone. That was my phone just like messing with me. I mean, I really like the band Perry. I think I played it like last week.
It just sounded like
Did? I really want to know how to
you
do
seem like
that.
you need music right now.
That actually happened to me during class, and they thought I was on my phone, and I almost got a unit for it, and I was like, I swear to you.
But come on, look at it from our perspective.
I know.
I mean, like, look at it from my perspective. Like, I'm sitting here and nothing's happening. Plug in -2. When you plug in -2, what do you get? Negative or positive? Negative and negative. So it's going to be.
Positive.
So this question is asking, where is it greater than 0? So can someone tell me where is it greater than 0? And by the way, that was all on record, by the way. So it's going to be negative infinity to negative 2, union
3/5
to infinity. Yep.
So that's where
So first it's x minus 1 equals, oh, you can just tell me, right?
1, 2,
1,
1.
2, 4.
2 and 4. So you make your line, right?
Clock, 1, 2, 4.
1, 2, and 4. Like this?
Yeah. And then
Now,
test number.
Test number. So let's just pick some numbers. So how about
Negative,
0,
1/2.
3 and 3 over 2, 3 and 5. And this is where making that chart is really helpful. So you have x minus 1, you have x minus 2, you have x minus 4, and you have the product. So then we have, what did I have? We have our numbers 0, 3 over 2, 3 and 5. Do this for me. Fill in that chart by, do that for yourself, okay? When you complete the square on this, you end up with y is equal to -2 times what, x minus 7 over 2 squared?
Plus 33 over.
33 over 2, right? So the, no, it's 66 over 4. So the vertex is 7 over 2, comma, 33 over 2. And it goes up or down? Down, and is it steep or shallow? It's steep. It's steep because -2 is greater than, the absolute value of 2 is greater than 1. That's why. So with that information, is it then not that hard to make a good sketch of this? Yeah, then you can make a sketch of it. Okay, this is what I like. It's a parabola like this. See, like this? What's the highest point? That one right there. So what's the range? The range is going up and down. So what's the range?
Negative infinity.
33 over 2.
What would
Oh, 'cause that's the y
limit this
value.
to not be
Yes.
all real numbers for
The domain, not in a quadratic. In a quadratic, it's always all real numbers. The two for the domain. Because what are the two things you can't do? You can't divide by,
0.
and you can't have the square root of a negative. That make you can, but it's imaginary, right? It's not in real numbers. Can either of these things happen with a quadratic? No. So what's the domain of a quadratic always?
All real numbers.
Yes. So when is that? When is that greater than 0? You have to use logic on this one because if you let's try. Let's do algebraically. Multiply both sides by x minus 4. What do you get? X minus 1 is greater than 0 times x minus 4. What's 0 times anything? 0. So we have x minus 1 is greater than 0. So x is greater than. Yes. X is greater than 1. The thing about that is, whenever you start multiplying by 0 like this, you might run into something that might not work. So if X is greater than 1, let's test something here. Let's see if it works. Plug in 2. 2 is greater than 1, right?
Yeah.
What's 2 minus 1?
1.
What's 2 minus 4?
-2.
Well, what's positive over negative?
Oh, that's.
It's not necessarily true. So when you do these out, if this is 0, you have to be really careful. So the way you do this one, and again, this is only one question. The way you do this one is you ask yourself, when is this positive? Well, it's positive when X is greater than 1, right?
Yeah.
When is X minus 4 positive?
Is when X is greater than 4.
So this fraction, a fraction is positive when it's positive over positive, or what? Negative over negative, right? So when are both of these true? When is both this and this true? When are they both true? When X is,
X is 0. No,
when are they both true?
X is 1. Or
Kids, here's 1, it's going this way. Here's 4, and it's going this way. When are they both true?
4.
1 to 4.
No.
When X is greater than 4.
Yes.
Yeah.
When X is greater than 4, that's true, and when X is greater than 4, that is also true. So it's definitely positive when this is true, but also we need to know, when is X minus 1 negative? When's that true?
Is when anything.
Negative 1, negative plus 1, thank you. And then what about X minus 4? When is that less than 0?
It's when it's
Less than
4. Less than
4. So when are both of these true?
4. Less than
When X is less than 4. So the answer to this is either one of these. Here's 1, and here is 4. So it's greater than 4, right? Less than 1. So how could you write that? Negative infinity to 1, union, or 4 to infinity. Yes. That's how they wrote it. Yeah, that's interval notation. Need to have what 3 columns do we have? Distance, rate, and time. What's the distance for both?
300 kilometers.
300 for both of them. Do we know the rate for Steve?
No.
So what do we write it as? Let's say R. What's the relationship between Steve's rate and Muhammad's rate?
20.
20 is a noun. Give me a sentence.
20 kilometers per hour faster than Muhammad.
So Steve rides his 20 hours. So what is Muhammad? R what? R minus 20, because Steve is faster. What's the do we know the time for Steve? No. It says find Steve's average rate if you Charles from Cranbrook in 1 hour's less time than Muhammad. So what's Muhammad's time going to be? T plus what? 1 1/4, so 5/4. It's really important that you see which one is bigger, because who's going slower? Muhammad's going slower because he's traveling slower. So then what's the relationship between distance, rate, and time? So the first thing we know is 300 on the first line is equal to R times T. And then we know 300 on the second one is equal to times T plus. There are lots of different ways to solve this. There's lots of different ways. Anybody have a suggestion about what we should do? Do not set them equal to each other immediately. Get one variable. Which variable do you want to solve in which equation? T in the... Yeah, let's do T in the first. I like that. So if you do T in the first, what does that equal?
300 over R.
And then where do I put this?
In the second.
In for T.
In for T. So then you have 300 is equal to R minus 20 times
300 over R.
plus. How many equations is this one in the circle? That's one equation, and how many variables? One. So theoretically, can you solve that?
Yeah.
Yeah, do you have to do it carefully?
Yeah.
Yeah, we've done ones very, very, very similar to that. You have to be very
Can
careful.
you keep going, because I never know what to do with that.
Sure, okay. So it's fine. So we have 300. What's one word? What do we have to do on the right?
Distribute.
Distribute. It's already been factored. So what's R times 300 over R?
300.
300. And with 300 plus 5 over 4R minus 6,000 over R minus 100 over 4. Hey, the 300s cancel. That's nice, right? So we have 0 equals 5 over 4R minus 6,000 R. Does everybody see where the 6,000 came from? Okay. And then, yeah, what's 100? 100 over 4 is 25. So what should we multiply everything by at this point? I would multiply it by R first. So what do we end up with? 0 is equal to 5 over 4 R squared minus 6,000 minus 25 r, and then what do you multiply by? 4. So you get 5r squared minus 100. No, not 1,000. Sorry, I'm 100r. I'm just putting it in different order. I'm putting that right there. Minus what? How much? 24,000. Right, exactly. So now you want to solve this. So what's that first method you like to try? Factor it. What could you factor out first? So you have 5 times r squared minus 20r minus, what is that? 4,800, yes. 4,800 because it's 24,000. Yeah, 28. So now you think, hey, it might be factorable. You try it.